All right, campers, check this out. This here is a temperature sensor. It's the FS304-SHTXX. No jokes, please. Remember how in our previous episode we got this Peltier cooler to make some super cold temperatures? It's time to actually regulate them. How do we regulate them? Well, hopefully you can remember that I was just pointing out that I have a new temperature sensor. So what we're gonna do is hook this up to our CPU board. Fortunately, that's really easy because they tell you how to hook it up right here on the label. There's VCC, ground, SDA, and SCK. Then there are a billion websites that show you the pinout for that. Here's what that looks like connected directly to the Arduino. We're going right through the old motor driver board header here. Then we need a little software library to talk to the sensor. Fortunately, I was able to find a library for this temperature sensor when I bought it. I didn't really look before I leaped. By the way, a couple of engineering friends have said to me, "Oh, why'd you buy a temperature sensor? All you need is just like a thermocouple." And I'm gonna rant here for a second because I have a lot of engineering friends who say things to me like, all you need is a diode, all you need is a capacitor. Yes, I am aware that a thermocouple is a device that responds to heat in an electrical way. But when you say things like that, it makes me want to beat my chest. Because when we're engineering a system, we need something that is repeatable and reliable and that can have a power supply, that can be calibrated, that has an interface to a microcontroller and everything like that. So that's why I went with this temperature sensor. It's got its own probe on it and it's got a digital interface and a library of software just ready to go. Rant over. Now let's take a look at the default output of this temperature sensor. The program is set up to continuously sample and show the voltages, to show the temperatures in Celsius. I see here that we're running between 21.7 and 21.6 degrees. Let's cross-check that with our handy-dandy infrared temperature sensor, and I'm seeing 21, 22 degrees. So they're within 0.3 degrees Celsius of each other. That's a good sign. Now I'm going to try heating up the sensor by holding my fingers on it. Very quickly, we see that it's reached 23 degrees and it's rising. There's 24 degrees, and I believe the human body is around 25 degrees. So now I've taken my hand off it, and we see it continue to rise a little bit, which means that there's a little bit of thermal mass in the system, which is inevitable. There's always going to be some thermal mass, but it's our job to design a regulator that can work around it. So we can see once I took my hand off, it only went up another 0.7 degrees. Not so bad. Now our next step is going to have to be to measure the temperature using the sensor while we're actually doing the cooling. Those are currently two separate programs, so we're going to have to combine those into one. Now presently, I have to go to a Christmas party, so I'll see you in the next episode.